Everyone, and welcome to my YouTube channel. So here today we are going to be looking at our introduction to dynamics. So now the introduction to dynamics, we are going to be looking at various things which are Newton's laws, first, second and third law. Then we are also going to refer to contact forces and non-contact forces. Then we are also going to delve a little bit deeper into friction. So now let's begin. So firstly, what is dynamics? So dynamics is the study of motion with respect to the cause, or rather with respect to the force that is causing that motion. So dynamics is the study of the motion with respect to the cause of the motion. So in this case, we are talking about the force causing the motion. So now, under dynamics, we are not just interested in the movement, as in how we used to look at kinematics, in which we are going to just look at how it is, how the facts that it is moving. But dynamics, we have to account for the forces that are causing that motion. So now, under this dynamics, we are just going to look at something that is very, very cardinal, which are Newton's laws. So we have the Newton's laws. So his first law of Newton's first law. So instead of writing in full, I'll say it, since we know that it's Newton's laws, we have the first law. So this simply talks about the fact that a body at rest will remain at rest and a body in motion will remain in motion with the same speed and in the same direction unless it is acted upon by an external force. This is very, very important. So this is Newton's first law. So in simpler terms, what we can just say is that for Newton's second law, we are just saying that if an object, you don't touch an object, it will not move. That is basically what Newton's first law is talking about. Funny as it may be, that's the genius definition. So if an object, if you don't touch the object, it will not move. So that is Newton's first law. Or in other words, if this is moving, if there is no external force, it will continue to move in that direction. So according to Newton's law, it says that the summation of the force, if you add all the forces, this will be able to be equal to 0, since we are going to have, in terms of the acceleration, since the acceleration is the rate of change of speed, but if it is moving at the same motion, it will be moving in the same motion. If it is 20 meters per second, it will be moving at 20 meters per second unless external force is applied. Therefore, the acceleration is 0. This is how come we have a 0 there. This simply tells you to say, under Newton's second law, we could have the velocity can be equal to 0, or we could have the velocity can be a constant, because if it is in motion, it will continue to be in motion unless acted upon by an external force. So let's look at his second law, which mostly forms most of the dynamics questions that we are going to be solving. So under Newton's second law, this one we are going to just say the acceleration of an object produced by a net force is directly proportional to the magnitude of the net force in the same direction as the net force and inversely proportional to the mass of the object. Now this is very, very important. Let's break this definition down. So already we are looking at the acceleration. So we are talking about the acceleration. So this definition might be lengthy, but it's very easy to understand. I'll explain further. So the acceleration of an object produced by a force is directly proportional to the magnitude of the net force in the same direction and as the net force and inversely proportional to the mass. So what are we talking about? Let's say we have an object here like this, then it is being acted upon by a force of, let's say, 8 newtons. Then this other side, let's say we have a force of 6 newtons, like that. Now, since one force wants to push it this side, the other force wants to push it this side, we are going to subtract them. So we are going to find that it will be 8 newtons minus 6 newtons. So it will be a 2 newtons. Now, where will these 2 newtons be acting? So by using our logic, we are going to find that the 2 newtons is acting in this direction, since 8 is greater than 6. That means to say the 2 newtons will be acting in this direction. So now, this 2 newtons is the net force. So we are saying that the acceleration of an object as produced by the net force, or rather is produced by the net force. So this net force is the one that produces the acceleration that is proportional to the magnitude of the net force in the same direction. So if the resultant force, or rather if the net force is acting in this direction, it means to say this is the direction that the body will be able to go. Then also we are going to find that the acceleration shall be directly proportional. If we have 2 newtons, the acceleration produced will also be, let's say, if it is 4 meters per second. If we increase the force, if the net force is increased to 6 newtons, you might find that the new acceleration might be something like 12 meters per second. So as long as you increase the force, there will be an increase in the acceleration, like that. So that is basically what Newton's second law. But it will be dependent also on how heavy the object is. So this is an inverse relationship. So the bigger it is, the more less acceleration that it shall be able to move with. So now if we look at this type of an arrangement, we are going to find that one thing that we forgot to mention, Newton's first law is called the law of inertia. So Newton's second law is called the law of inertia, meaning to say how heavy it is. If an object is heavy, so inertia is simply the tendency of an object to resist being moved, or rather to resist motion. So the bigger it is, the greater the inertia. So now that is Newton's second law, but it will be independent. It is inversely proportional, meaning to say if the mass is greater, the less the acceleration, like that. Then what we are going to have is that is Newton's second law. So according to Newton's second law, we are going to say the net force is equal to, we know that force is equal to ma, so the net force is the one that is producing the ma. So in other words, we say the summation of forces is equal to mass times the acceleration. If you add the forces in that way, in this case we were subtracting, but if these forces are acting in this direction, let's say both of them are in support, we have a 6 newtons, we have 8 newtons. These are going to combine to form, let's say, a 14 newton resultant force, or rather the net force, like that. So the summation of the force in that case would be equal to a 14, like that. So that is it. So we know that the units for force is equal to our mg, like that, or sorry, is equal to the newtons. So this is the units for the force. Looking at third law, we are going to say for the third law, we are going to have a situation whereby we are going to say whenever a body exerts a force on a second body, the first body experiences a force that is equal in magnitude and opposite in direction to the force that the first body accelerates. in simpler terms, we can just say for every action, there is an equal but opposite reaction. So we have for every reaction, there is an equal. So for every action, there is an equal but opposite reaction. So that is basically what Newton's third law talks about. So now, a common exam question is what we are going to say. First, before we look at that, let's say we have a table that is sitting downwards, sitting on a table. Let's say we have a block sitting on a table like that. Then this block, what will happen is that already it is experiencing a force downwards which is equal to its weight like that. Now you might wonder to say, why isn't this block, let me use this one as reference, why doesn't this block enter inside the table like that? In this case, maybe here. Why isn't that the case? There is an equal but opposite reaction. So if there is a downwards force down there, then there should be an upwards force like that. So this upward force is what we are going to call the normal force. So this is the situation, and that's why they do not cancel each other in that way. Or rather, that's why it does not enter inside like that. For every action, there is an equal but opposite reaction like that. Then what we have, this weight is simply defined as the force of gravity acting on an object. Force of gravity acting on an object. So acting on an object. So that is what we are going to call our gravity like that. Now, when we look at other things such as we have the common question is, we know that for every action there is an equal but opposite reaction. They'll ask you to say, why don't action and reaction forces cancel each other? This is a really good question. You might wonder to say, if there is an equal but opposite reaction, why don't they cancel each other? Like, for example, if let's say a person is pushing an object, let's say we have a person like, so let's say we have that, it is moving in that direction. Now the question that you might have is, how is it that it is being moved? If for every action, if you are pushing, more like if you are pushing like that, there is another force that is pushing you back of equal magnitude. Why isn't it just on one point if for every action there is an equal but opposite reaction? So now, to answer this, what we need to understand is that action and reaction forces So now, so the types of forces. So forces can be either we have what we call contact or non-contact. So on the non-contact, we might have non-contact. We are referring to those that are to do with nature. Like the examples that we might have under non-contact forces is the force of number one, gravity as our first force. Then we are also going to have something like electromagnetic force. We might also have strong and weak nuclear forces. Strong and weak nuclear forces. Strong and weak nuclear forces, like that. Then we, apart from that, we also have what we call the contact forces. These contact forces are the forces in which contact must be made. So the examples that we might have is friction. We might also have what we are going to call what else under contact forces. So the example of contact force is what we are going to call the tension as well. So tension is also a contact force in that regard. We also have the normal force. So the normal force is a contact force. Let's dive deeper into this, then we just look at static coefficients of friction. So let's define these contact forces. So we have friction. So friction is the force that resists relative motion between two bodies in contact. So that is basically what friction is. So to elaborate more on this, we are going to have, if a body, let's say if a body is moving in this direction, so if it is moving like that, there will be the force that will be preventing a relative motion between two bodies in contact. So meaning to say between where it is passing and the surface of that object. So that is basically what friction is. We have our tension. So tension is simply the force that is transferred using a cord or a rope. So just as we have said, it is a force along a length of a medium. We might have a rope, we might have a cable, we might have a string, or we might have a chain like that. So now what we have is, let's say we have this diagram, then we have something like this, then we have a rope connected like that. So if someone is more like holding the item with their hand like that, then this one, there will be the tension. So as the person is trying, let's say this person is trying to pull this direction, so according to Newton's law, you will find that there will be a force, that is his third law, there will be a force that will be acting in the opposite direction like that. So same, when it reaches this point, this same force is the one that is going to more like return. When it reaches this point, it is going to more like bounce back. So that is why we even said that the tension, or rather whenever, let's say you push something, which is just the basis of dynamics. So if you push something like that, then what we expect to have is that this thing will be able to push back. So as funny as that might sound, that is the working of physics. You push something, it pushes you back. So that is how tension works. So remember these concepts, because they are going to be used when we answer further problems in the next video. So now when we look at the normal force, so the normal force is simply a force that acts perpendicularly and also prevents a material from falling. So that is the normal force. So the normal force is number one, it is mostly perpendicular. It is perpendicular, and it also prevents falling of objects. So when an object is stationary at one point, it exerts a downwards force, then there will be the upward force, which we are going to call the normal force, like that, which might differ in one situation to another. So basically that is that. Then for our last part, we are going to look at for friction. Let's just go into a bit of details. So friction, we are going to talk about static friction. So to simplify static friction, we are simply looking at the friction for a body that is not moving. So static friction occurs when a body is not moving. So when the body is not moving, like that. So as long as the body is not moving, then we are going to experience what we are going to call static friction, like that. So just as we said in our example, if you have a block like that, then there is let's say you have a block like that, then there is someone here. So now what begins to happen is that as this person is pushing like that already, so this is very, very important. If you push, let's say with a 5 newtons, like that, 5 newtons, also the box or whatever you are trying to move will also push you back with 5 newtons and it won't move. So static friction occurs when a body is not moving. So this is happening when it is not moving. If let's say this person decides to increase the force to 20 newtons, then also the box will match these 20 newtons, like that. Now already one might wonder to say, why doesn't it push the person back? Because already when they applied 5, it had the option of more like going to 20, but it doesn't work like that. That would be total witchcraft, because how is a box able to push you? So it will more like depend with the force you apply. So that is the static friction. Now you will find that the more you increase, also the resistance, which is the inertia, it increases, because the tendency of a body to resist being moved from one point to the other, that is what we call inertia, like that. So with that said, we are now going to look at, so the object is like that. Then we are going to find that, let's say you apply 40 newtons. This is, let's say this is the maximum amount of force that you can apply without this moving. So let's say this is the maximum, then you can find the coefficient of static friction through various experiments. Now what we are going to have is that, what you should know is that the frictional force is equal to the weight, it is equal to the mu s times the normal force. So the normal force in this case is equal to, so if you draw something like this, remember it is experiencing a downward force, weight, which is equal to mg, like that. Then upwards we shall experience a force which we are going to call the normal force, like that. So for anything we are going to have this is our formula, just in case there's anything. We have, let's say we have mu s, we might have mg, we might have anything for our fn, depending on the thing that we are calculating. So this is the coefficient of static friction. Now you will realize to say, when a body is not moving, it is very difficult for you to make it to start to move, in comparison with to move an object that is already moving. Therefore, the coefficient of static friction is greater than the coefficient of the kinetic friction. So this is what we talk about. So now it is very difficult for you to move an object that was not moving. That's number one. Number two, it is very difficult for you to be able to, or it is easier for you to move an object that is already moving like that. So if we have such type of a situation, we go up like that. So now this graph shows you what the force is equivalent to. So as you are applying your force, we are going to have the frictional force is increasing as a result of Fs is going to be increasing itself depending on the force that you apply. Let's say the force here is the Fs max, which should be equal to mu s, times the normal force, like that. So this one is showing how difficult it is for you to start an object, or how difficult it is for an object to to just start to move. Then here we have regions. So these regions are static region when it's not moving. So it is when only the static knowledge is eliminated. That's the best approach. When it is eliminated, then we can teach properly there. So now what we are going to have is that then down here we are going to find that our force will be reduced like that. Now why is the frictional force reducing? So when it is here, it is static, it's not moving. As it starts to move, the frictional force, which is the kinetic friction, which works under the situation where we have the frictional force, it is going to more like reduce. So this one, we are going to call this one as our Fk, which is equal to the coefficient of kinetic friction times the normal force, like that. So this is our other formula for that one. So it will reduce like that. So now the value that you should expect, one thing that you should know is that do not come out of the exam smiling when you find your coefficient to be equal to something like a 5. You are in danger if you have something like that. So it should be from 0 to 1. So we are looking at numbers in between. So you can have the coefficient, or should I say you can have coefficient of static friction. The values are from 0 to let's say mu s. Yeah, so mainly we are just looking at our mu s. So our mu s, then we have less than 1, meaning to say less than or equal to, the maximum might be 1, the lowest might be a 0. That means to say there's no friction. So mainly you should expect answers 0.1, 0.2, in between these ranges. So now this is what we have for that. You might have 0.6 or something like that, but it should be within the acceptable range, like that. So this is how we do that one. So then the kinetic frictional force is also equal to, we are going to have the mu, now the one, it will be k, where this is the coefficient of kinetic friction times the normal force, like that. So this is the formula for Fk. So you can watch other videos which I've already uploaded in order for you to continue with your dynamics, drawing free body diagrams and all that. Thank you very much for watching. Hope you would like, subscribe and share for more. See you in the next tutorial.